Uh, Jukka, I would like to introduce you for today. So Jukka is in Aalto, uh, Aalto University. Basically, his job is to make people or students better there. And basically, he knows something about programming because he has got a PhD. So Jukka, welcome.
Okay, thank you for the introduction. Right, so having a PhD makes me an expert or not. But yeah, my talk about from the 80s to today, I was almost going to rephrase the title to something a bit similar. That from the 80s should we go back to the 80s? And of course, this is slightly a provocative title, maybe, but let me elaborate on what I see that we might learn from something from the 80s and 90s today. Now, when I started my life as a programmer, of course, that was the screen that I saw, and many people saw the first time. Hilarious 38911 basic bytes free, so you have 38 KB to do your magic, and that's where life began. Of course, later on, there were some much fancier devices like the Atari that me and some of the friends, we had these Ataris 520s, which was kind of the top end machines back then. Of course, many people in Finland had rather the Amiga 500s, and of course most people had these, but that was the high end back then. Of course, the commonality to all these platforms is that, at least from today's perspective, but also back then, they were rather limited. Or of course, in one sense, because you didn't have anything else. Of course, with an Atari, you could do a lot of music things, and the Amiga was supreme in graphical capabilities, and so forth. Had even was it 2 megabytes of main memory, so that was big. But on one hand, it was limited, but there were still people who could do magic in with those platforms. And if you look at what the industry was providing, or the game companies back then of course the demo scene back then was creating magic, if you will, out of those platforms and out of the hardware you had actually. So those were the guys who actually could harness the full potential of the platform. I mean, you can do flashback to the old days, Googling, for example, demo scene and Amiga, and you'll see all these, potentially familiar intros and demos that, the best and most knowledgeable, people could do back then. And if you really consider the platform and the hardware you had back then, these were, nothing short of magic. Now, back then, programming was really about harnessing the full potential of the platform. It was we had much more ideas and skills, or at least some of us had. I'm not saying that I had, but many people had more ideas, more skills, and you really didn't have the performance and capacity to do all that magic. So you really had to be clever when you started. When you wanted to do something really cool and something no one had never seen before. If you consider, for example, the change to today, let's say, from 1990 to today, if you do the math with, using Moore's law, we roughly have 1 million-fold more processing capacity than we had, in 1990. 1 million X, not million percent, but 1 million X. I mean, think about it. Storage, kind of similar. I mean, back, late 80s, 90s, the 1.44 meg floppy was pretty much high-end storage, and nowadays 1 or 2 terabyte of hard drives. That's nothing spectacular today. So give or take a million-fold increase. Also, if you look at the so-called Nielsen's law of internet bandwidth and how that roughly has evolved, so it talks about what is the available high-end connectivity that you have and how that grows. It's slightly less than Moore's law, but it's still a serious growth curve. It's not quite a million-fold increase from 1990 to today, but not very far from that. So everything is has grown tremendously. If you think about any other industry that would have a million X increase in performance or capacity in 30 years, that's would be unheard of. When I started as a professor in Aalto back in 2006, that was the high-end smartphone I had back then, really the high-end Nokias. And nowadays I'm carrying a Huawei Mate 20 Pro in my pocket. Cool enough, if you look at the specs back then, when I started my career, 220 megahertz dual ARM and 64 meg RAM. And now I'm carrying 8 cores worth how many gigahertz, and the amount of RAM I have is 1,000-fold change in how much RAM I have on the device. And even today seems like my device is not always up to the task of the daily activities. Now, if you think about the skills that people had back in the old days, or at least when I started my career as programmer and in computer science, and if you think about the million-fold increase in almost any measure of ICT performance, whether it's storage or bit rate or computing capacity, then you would expect that we have lightning fast services and applications today. I mean, really lightning fast. They boot up in a fraction of a second, and everything happens, faster than the blink of an eye. But do they? I mean, where are these lightning fast things that a million-fold increase in performance would, of course, just looking at the math, would enable us? But still today, it seems that programming is not anymore about the platform. It's not anymore about the performance. It's about potential or capacity of the programmer. Or we might consider that it's actually about the budget. You don't care that much anymore about performance. You don't care about capacity. It's you need to stay within the budget, and you use this offshore and whatever means of getting the cheapest programmer and most lines of code with a certain amount of money. So it's really more about the time and budget nowadays, time to market, and within a certain budget than the absolute performance capacity of the software product you are doing, or whether it's a full-blown system. I have some examples coming. The only exception I could think of, I was really trying hard to think of, is maybe IoT, because in IoT, in many cases, you have these battery-powered, very small devices. So you are kind of forced, which is a good thing, to think about your implementation. Actually, you really need to think about it and not just have a quick brainstorm and then you go and implement and launch the product next week. But actually, you probably need to think even once or twice and how you really do that. Well, let's use the World Wide Web as an example of what I'm getting at. Given the increase in a million-fold increase, you would expect that, of course, we have websites which load in a fraction of a second, and everything is lightning fast and enjoyable and so forth. Of course, many of you know that that's not true, but let's look at some of the numbers. Just for the fun of it, I was looking. I tried to find what was the browser specs back earlier in my career in Otaniemi, and I could find, for example, Netscape Communicator from 2008. File download size 5.78 megabytes. It needs 64 megs of RAM and a Pentium processor. That's your web browser 2008. Anyone who understands about software today kind of realize that your browser today will not run on 64 megs of RAM. It will not run on a single 200 megahertz processor, and it will not be satisfied with 50 meg of hard drive space. I couldn't find really the specs. I was looking at my Mac, and that one says that the Google Chrome, after I clear all the caches, uses about 454 megs of storage. I mean, it's a web browser. Same as behind that, the Netscape communicator, which was 578 meg download and maybe 10, 20 megs on the hard disk. So that's your web browser today, which is kind of insane, but that's another story. If you look at, for example, from HTTP archive, you look at the evolution of web pages, then that's the median. If you look at the median desktop page size in the last 9 to 10 years, that has roughly grown by 300%. But look at the mobile web page. The growth is about 1,000%. 1,000%, tenfold increase in the size. And if you look at the comparison, I've been naive in the past that I was thinking that mobile web page means that it's a lighter version and lighter version for mobile devices, but that's mumbo jumbo. Mobile website is nowhere lighter than a desktop version, which is kind of sad if you think about it. Then if you look at the time to load, so looking at the onload event on the browser, median desktop, if you consider the 100x increase in 10 years of computing, storage, network speeds and stuff, then that hasn't changed pretty much at all. It's still roughly in the 6 second range, the desktop. Partly because the web pages are so bloated and the whole World Wide Web is pretty much screwed up currently. But if you look at the mobile web page, then that has grown by 400%. At least based on these statistics, the median is almost 20 seconds, which is kind of sad if you look at it. So that's where the technology is considering what the electrical engineers have been able to do in 10 years or 20 years. Is the answer nowadays that if the service is slow or the app is not working, your hardware is a problem? It's not the software that is the problem, it's the hardware. So you just go and buy more and better hardware. You need a faster network, you need better, more storage, you need better processor and so forth, whether it's your mobile, whether it's your laptop, and so forth, potentially the TVs and stuff today also. So kind of the problem that I've shown, or the growth of everything, despite the increase in electrical engineering and the hardware performance, then the answer today is just, buy better hardware. It's your problem, not the software problem. So I would almost claim that the whole software industry is pretty much eating all the benefits that the electrical engineering field has been created over the past, 30, 40 years. So whenever, electrical engineers are able to build, better processors, faster networks, more storage, then the software industry is pretty much eating everything up. And back to the drawing board of figuring out how you can do it even faster and even better in the future because of software. I mean, the hardware is nothing without software, and the hardware is only used to build services, provide software to build these services. So of course you could ask, why are we in this situation? And it depends on who you're asking. Of course, you can claim the customer, you can claim the, companies, you can claim the, universities, pick your choice. But in general, you could see the software engineering as doing pretty much the same as any other industry has done in the history of this planet. I mean, car industry is an easy analogy here to use. If you think about it, cars, back 100 years ago, cars were new. The whole industry was thinking about how to manufacture them, and the Ford was building the first, full lines of, building cars quickly. You were thinking about the engines, all these, ownership and models and stuff like that, and that has been going for, it went almost 100 years until, last maybe 20 years, the talk has been much more into resource efficiency. People know how to manufacture cars, Now the question starts to be, how do you make them resource efficient, whether it's in terms of materials or whether in terms of burning fuels, or going into these hybrids and electric cars. So the car industry nowadays is much more focused on resource efficiency, and that is the mantra that they are advocating. It's not really growth and more and more and more. So in a way, you could ask whether the ICT industry is still in this early phase of the car industry, that more cars and cheaper cars, so more software, more code, more lines of code, and trying to make it as cheap as possible, so you win bids and you get this done in within a certain budget, without really caring how much resources they consume, whether it's cars with the gas or whether it's electricity and hardware performance. You might ask the question whether the problem in the ICT is that the buyers are not educated enough to demand more. If you think about the car industry nowadays, then buyers really know what they want, and if you try to sell in Finland a 3-liter gas engine, then good luck selling that, because no one buys that anymore. And of course that was a downfall of the whole US car industry, because selling these 3, 4, 5-liter gas engines wasn't something that Europeans or Japan and so forth wanted anymore to buy, and they figured that one too late, and of course had to change everything. So of course the question is both on the consumer side, if you go back to whether it's car industry or ICT, both it's both a consumer question, and the corporations or governments who are having these bids for companies to build certain services and build apps and so forth, then are you really understanding what you are bidding, what you are having the bid for, what are your requirements? And people are offering solutions and services and doing them within a certain budget, but are you getting just crap out of it? It's within budget, but you are getting crap, and then you are screwed, because you need to buy a full data center again to run a new service. Same for consumers. You don't really see consumers having understanding how these energy performance issues, and you can't really make a decision that, hey, I will download this game because it uses less processing power and less storage, for example. You don't really see that happening. Maybe in the future. Now, if you come back to the university question, of course, me as a professor at the Aalto, then of course education follows typically the needs of the industry. We have a constant dialogue with the industry and understand what type of experts the industry needs and wants to hire. Of course, we need to keep our own mind. That's in certain places, and in certain places, of course, we need to make sure that the Finnish industry and the Finnish software and ICT industry is getting the high quality experts from the universities that they need to maintain their competitive edge on the global scale. Now, if you look at, for example, programming education, back when I started programming, or if you think about how you used the old platforms, and of course assembler was the way to get the performance out. Of course, there was when I studied at the University of Helsinki in computer science, there was Pascal. I don't remember, did we have Fortran, but at least we had Pascal and stuff. And then I guess there might be some version of BASIC back then. Then the teaching went to C, and we could do on one hand higher level things, but on one hand, when you were able to do low level programming, you could actually affect the performance of the applications. And we had a lot of teaching and thinking, especially related to network applications, how you actually how you can screw them up and how you can make them efficient. Then the teaching actually moved, or if you think about the first language that students were learning, then that actually moved to Java. Then at some point it was deemed that Java might be still too complicated, and you actually the first language seems to be Python nowadays, and I don't know if JavaScript is also there and so forth. So if you look at the kind of change, it has really moved from a very low level abstraction. You could also do count the number of libraries available in that in that programming language. So it has really gone from a very low level abstraction to a very high level. Programmers don't anymore see or know, understand the platform. They just write code, and more is better. Then, of course, in terms of course, code per hour, that is totally different. Then, of course, with assembler, you could write a lot of lines of code, but not get much happening on the screen. And with Python, you can write a few lines of code and get stuff happening on the screen already. So I didn't use lines of code here, but some kind of functionality per hour. Then, of course, that has increased when you take the abstraction level higher. That just also ran when I was doing my background research for this. It was an interesting statistic from Indeed on the average salary and job openings this January in the US. Then you can see that actually Python programmers are the #1 sought resource, which is kind of interesting. And then Java, JavaScript, and my favorite language, C, is only at the level 6th. And even salary expectations then for C programmers, which I do appreciate, then actually their salary expectation is lower than Python programmers. So that is what the industry is looking for. So you can find similar statistics like this was the programming language popularity from GitHub, and there you can also see that the most popular language seems to be Python, and then Java, JavaScript, C#, PHP, and my C language is again, low on the list. Of course, you might ask the question: so what is the role of programming languages? Potentially, all these, different frameworks. If you build a web application, you have probably 100 different frameworks you can choose from, and they get the new framework every month, and which is again better on whatever metrics than the previous ones. And of course, skills and so forth. So what is that role? I don't have an answer for it, but I'm just raising the question. So summarizing and going to the end of my talk, I'm asking the question: is ICT on its road to become the next environmental problem, or is actually software becoming the next problem? Because hardware performance increases by 100-fold every 10 years, or at least Moore's law brings 100-fold increase in performance every 10 years, then why is that performance not seen in the services? And everything is slow, everything eats up even more, and all the AIs and stuff like that. I mean, you have more AI concepts available and potential than there is processing power on this planet. So what I'm asking and what I'm kind of advocating is, could software engineering become again resource efficient? Could you start doing things that where you need less, so kind of less is more, from the perspective that my application needs only this and this much of network storage, or processing power, or even bitrate from the network. I've seen many cases where you can build the same service, and we even have a research paper wrote back in the days when we're just looking at how many clients you can serve a video stream with certain hardware and certain software, and there was a huge differences just by picking the right software or configuring a software and looking at the different hardwares. So kind of as a last slide, I'm asking whether we should go back to the 80s and go back to thinking about programming also from the hardware performance and output perspective, and think about what is needed to run my service, instead of whether it's in budget and how cool the UIs are. Because with cool UIs you can hide the rotten core, if you will. But that's the end of my talk. I'm happy to take questions.
All right. There is one question. Can you hear the question, right, Jukka?
Yeah.
Okay.
Only
cool.
one.
So yeah, there is for now there is one. There will be more. My Amiga 4000 booted in 3 seconds in 94. My Mac boots in 20 seconds. Why are we wasting our time waiting our blown out systems instead of having lightning fast experience. What could be done to do that?
Sorry, so there was something about booting up and...
Yeah, so in a nutshell, Amiga 4000 booted in 3 seconds in 94. And then the MacBook boots in 20 seconds now. So
with an SSD drive.
Yes. So what could be done to fix that?
Well, actually this is my message on this last slide, that software engineering today, and partly because the customers don't understand what they are, for example, buying. Then software, in my opinion, of course, I'm exaggerating. There are use cases where you have the opposite, but in the big picture, there is not enough focus in programming and software engineering today to think about how resource efficient my software or service is.
So
in the big picture, that is the problem, and that's where whether it's companies, but it's also customers need to understand how you order, for example, systems. And for example, let's say government orders a new big service platform. Then the question is how many servers you need to run that, and that is a factor in evaluating the bids. If someone says 100 servers and someone says a data center and someone says, well, we can run it with one server.
So do you think the background reason is that it is actually cheaper to buy more hardware than to do kind of energy efficient programming?
Well, the cost is on the customer. And that is actually it might be that actually it's cheaper for the end customer if you pay more for the software and they need to buy less hardware. That is actually a very valid point, and actually it would be an interesting research question that, let's say, if you pay 50% more for your software and then you need 50% less hardware, or need only 10% of the hardware that you would have needed otherwise, then would that make actually a good deal?
That's an interesting point. There's one final question, and it's about what the whole industry should learn from the findings you have made. How the tomorrow should be different?
Well, I don't know if my slides are still very visible, but the second to last slide I had is the less is more. Who has the kind of strength and courage to take the step in discussing and having the notion of performance in the software, in the bids, in the offers, and because when someone starts doing that, like let's say Toyota Prius was launched in '97, and of course it took a long time before every company now has hybrids, and some people go all the way only hybrid cars.
Yeah.
Then when some people start having that and advocating that, hey, we do premium code, we do premium software from the hardware performance, and you need less servers to run our solution, then that is when everybody else needs to do the same thing. Okay,
so basically, in a nutshell, that we want to have the greener software industry tomorrow. Jukka, it was so great to have you here. And if there are any other comments, please ask in Twitter. It's Blue Arrow Awards.